Okay, Rachel, let's quickly go through a couple of terminologies so that you'll be sure that you understand certain, some other way in which they say things so that you don't get confused. In the last section, I showed you the relationship between an inscribed angle, and the measure of an arc, which is related to the central angle. Okay, now I want to go a little further with defining certain things related to the inscribed angle. An inscribed angle like this one, angle 1, you see why is it inscribed? Because we have 2 points A and B that define an arc, and then we draw a line from one of the points to touch the circle somewhere. It could be anywhere. Remember, that's why we said we can draw an infinite number of inscribed angles. So you draw one of those, and then you draw from that point back to the other point on the arc, and you have an inscribed angle. It's as simple as that. That's the definition. Any such angle is an inscribed angle associated with arc AB. Now, so I said an inscribed angle 1, that one, and its intercepted arc. That's the other term I want to make sure is clear to you. Intercepted arc. So with every inscribed angle, you have an intercepted arc. Okay, why is it called intercepted? Because the 2 points at which define the 2 lines that define that angle, the 2 lines, this one and that one, that define this angle, intercept the circle at point A and B, and therefore AB is the intercepted arc associated with the inscribed angle. That should be very clear to you now. So they can use the term intercepted arc in association with that, and you know what it means. Okay. The other one, the other way they describe things that I want to make sure you get is down here. So if you had a circle and you have 2 points on it defining an arc, so AB, for example, is an arc. Never mind whatever else they are describing to you in here, in the circle or around it, but if they put a number, an angle, the value of an angle somewhere out here, like 80 degrees, what that is saying is that the measure of arc AB, the measure of arc AB is 80 degrees. That's all it's telling you. And remember, what did we say earlier about the measure of arc AB? It has to do with if you were to come back to the center and draw that, the 2 radii, what will this angle be? It's 80. Okay, so that is what that is all about. So, but they could, instead of doing it like this for you, they could just put 80 out here next to the arc. So you know that's what it means, okay? You should already have seen that in the previous sections, again, 10.1, 10.2, 10.3. Rachel, let's look at Theorem 10.8. Theorem 10.8 has to do with a situation where you have 2 inscribed angles of the same arc. So there's the arc, and then you have this one angle at D, and then you have this one angle at C. Okay, that's the setup. So those 2 angles are inscribed angles. As you recall, an inscribed angle is you start with 1 point on the circle, you draw a line to another point on the circle, and then back to the other point that defines the arc related to that angle. Okay, so that's an inscribed angle, that's another inscribed angle, both of them intercepting the same arc AB. So what does the theorem then say? The theorem says if 2 inscribed angles of a circle, if 2 inscribed angles of a circle intercept the same arc, so again, those are the 2 inscribed angles. C and D, they intersect the same arc, arc AB, then the two inscribed angles are congruent. Okay, that is, if these two inscribed angles are related to the same arc, then these two angles must be congruent. C and D must be congruent. Really, this should be easy for you to see. It comes directly from Theorem 10.7. Remember what Theorem 10.7 said? It said that if you were to draw the angle to the center, not to the edge, not to the circumference of the circle, but any arc, take the measure of that arc, which means the central angle, then that central angle will be twice the value of an inscribed angle related to the same arc. Okay, I went through that for you on Theorem 10.7. So if that is the case, then since it's the same arc that is related to these two angles, the same arc AB is related to C, to both inscribed angle C and inscribed angle D, it means that the central angle related to AB is the same central angle that is related to these two angles, and that central angle is twice the value of each of these two angles. The central angle, because that's what Theorem 10.7 says, that is, the central angle will be twice the angle of the inscribed angle for the same arc. So it means the same central angle, okay, is related to each of these by being twice of each of these. So therefore this must be equal. If the values at the center is twice each of the values at the edges, then it means that those two values at the edges must be equal too. Okay, I hope that's very clear.